Hey people, welcome to our today's tutorial. Dr. Brennan here. Let's try to look at one of the questions that came in one of the past papers in pharmaceutical chemistry and analysis for pharmacy students third year. So this is this reaction. The question was propose a reasonable mechanism for this reaction. So here, this is phenylhydrazine, or what we can call as aryl and the ketone. This is acid catalyzed reaction forming this compound here. This compound is the derivative of an indole. So in the synthesis of an indole, we use the good reaction that is known as Fischer synthesis of indole. So it's called Fischer synthesis of indole. So in Fischer synthesis of indole, we use phenylhydrazine and a ketone to come up with an indole. So this is an acid catalyzed reaction. What does the acid do to the reaction, or how does acid catalyze the reaction? What it do is to activate an electrophile through protonation. So what we need is, the first thing is to protonate. So here we're going to use this. That's the first step. We're going to get this, which is a ketone. Going to get this is the ketone, which is here. So this ketone, all the oxygen has got lone pairs of electrons. So here we're going to say, I'm going to bring this acid, which is like this, and these electrons will come and grab this hydrogen there, and what we are going to have, the bond will break and the electrons will go toward the oxygen there. So here, if you want, you can show it up there like this. It's the same thing. Then what are we going to have? We are going to have the protonated ketone, which is like this, like that, or we can say yeah. So after grabbing the hydrogen, we are going to have this, which is water there. Don't forget, we're going to use it at some point, that water that we have formed. Then when we reach there, we're going to go to the next step, that is we're going to get this phenylhydrazine. So this phenylhydrazine, it will come here, which is NH and NH2. Then I'm going to bring this now, which is okay, I'm going to bring this. Okay, something like this. Okay, it's the same thing, you get? So what I'm going to do is, you need to get the lone pairs for the nitrogen that has two hydrogen, which is connected to another nitrogen there, this one. This is the one that you're going to use and attack the carbon that has this, which is OH, which is protonated like that, okay? So that what will happen to this bond, it will open like this. Then we have attached this, and what are you going to have? Please pay attention to this one. We are going to have this, okay, which is N, and also here we have with two hydrogen. So here, because of being two hydrogen connect, so this nitrogen will be connected to 4 bonds. So what we are going to do, it will have a positive here, then here, like we have seen here, here will be the methyl, that's that one. Then here, since it has opened, we're going to have OH there. Then here it will be like this, okay, like that, something like this. Here, that's what is there. So when we reach there, the first thing that we're going to do is to neutralize this charge which is on the nitrogen there by obstructing this one or hydrogen there. What have we remained with after protonating getting this hydrogen? We have water. So this water is the one that I'm going to bring here. So that's the one that I'm going to bring there with one lone pair of electrons. So this bond will come and neutralize here, or the electrons will come and neutralize the charge on the nitrogen. So what we are going to have, I'm going to have something like this. Okay, so here there is like this, don't forget. Okay, I can't forget this thing. Okay, that's that. So here we're going to have this, then okay, this. So when you reach at that point, we need to remove this OH there. But since we're using an acid, it's an acid catalyzed reaction, we can't leave on its own. It needs to be protonated. So what we're going to do, we have acid here. After getting this hydrogen, we have remained with the acid there. So here I'm going to bring this, which is an acid, here like this. So what I'm going to do, I'm going to get these lone pairs from the oxygen there and get this hydrogen there like this. Then this bond will come, the electrons will come and neutralize the oxygen there like that. So what we are going to have, we are going to have this. Okay, so here we have OH2, then here like this. Okay, like that, you see? So okay, like that. So when you reach at that point, we're going to say we want to remove this OH2 now, which is protonated. So here I'm going to bring the water that I've remained with. After protonating it, I've remained with water. So this is water that I'm having here with these lone pairs. So I'm going to get this to obstruct one hydrogen there. So this hydrogen, when it's being obstructed, we're going to say this, or the hydrogen from this, or from this nitrogen, so that this one can come and make a double bond there. So when it makes a double bond, okay, so here it's like this. When it makes a double bond, this bond will break and all the electron will come to oxygen, so it will go, you get. So I'm going to remain with this, which is here like this, and here. Okay, like that. So that's what we are having right now. So here there is a reaction that we are going to show with these arrows, the long arrow and the short arrow, which looks like a reversible. This one means is a tautomerism. So tautomerism is changing where the double bond is from the nitrogen and carbon to the carbon and carbon. So it will be changed. The double bond will be on the carbon to carbon, from the nitrogen to carbon, and the hydrogen which will be on the carbon, it will shift to nitrogen. So here, this tautomerism, it means that this bond which is on the nitrogen and the carbon, it will shift here, which is on the carbon to carbon, and the hydrogen which is here, you know there are how many hydrogen here? There are 2 hydrogen. So since there are 2 hydrogen, but when you bring when you bring a double bond there, another hydrogen will shift to nitrogen like that. So that is tautomerism, but there we don't show that the hydrogen has shifted or the bond has shifted, but you need just to bear in mind that the bond will shift from nitrogen to carbon to carbon to carbon. So what we are going to have, we are going to have this like this. So nitrogen will have a hydrogen there, then here there will be a single bond, so the bond will be here now. So something like this. To be like this. Okay, something like that, you get. So that is tautomerism, like those arrows show like that. Then there, what you need to do is, you've seen this is more electronegative, and also this one is more electronegative. So since this one is more electronegative and this one is more electronegative, and electronegativity is the ability of an element or an atom to pull the electrons to its own. So this one will be pulling electrons to its own, and this one will be pulling electrons to its own, making this bond which is here to be very, very weak. So since it's pulling, each nitrogen will be pulling electrons toward its own, and the bond there will be weak, so the bond will break. So when the bond breaks like this, I'm showing that the bond breaks like that, we'll make a double bond there. Then since now the carbon here will have 5 bonds, so this one also will go and react here with this, and this bond will be there like that, you see. So this one will go to make a double bond there, so here to have five bonds. That's why this one has shifted to react with this. Then this one also to have 5 bonds, even this double bond will come like that. So what we are going to have, we are going to have this, we are going to have this. So here with the double bond, so here to be like this. So here we have like this. Okay, that's where we are right now. So there it has broken, then like making a double bond there has gone, so we don't have a double bond there. Then this one, after reaching there, so here there's something like that. After reaching there, then this one, the bond which was here has shifted to nitrogen and the carbon like that, you get. So reaching at that point, what we are going to do is, we want now to make our product. Remember our product, how it looks, it's like this, you get. So what we are going to do is, here there is a bond which has broken here, so we need to put the bond there. So now the first thing that we're going to do here is, we have remained with the high since after getting this hydrogen, we have an acid now. So here I'm going to bring this acid, and I'm going to use these lone pairs for nitrogen there, and come and grab this hydrogen there, and this bond, all the electrons will neutralize the charge. Then what am I going to have? I'm going to have something like this. Then here it will be like this. Okay, so what am I having? With 2 hydrogen like this. So here to be positive like that, then here there is something like that. Okay, that's where we are right now. So what I'm going to do is, for me now to remove this, so here I'm going to expose this hydrogen there for easy attack, so that I can make a bond. You've seen that there's a bond here, so that's the bond that I want to make now. So how am I going to do? I'm just going to get that water that I've remained with. This is water that I've remained with after getting the hydrogen. So I'm going to bring it here. This is water, and getting this hydrogen there. So this one will make a bond here, the double bond. So here now, when it makes a double bond, this one, where there's a double bond between nitrogen and carbon, there will be 5 bonds. So this bond which is here will come and attack here. Then this one will open like this, you get. When it opens, all the electrons will go to the nitrogen like that. So what we are going to have, something like this. Okay, so here there is it like this, then here it'll be like this. Here there is NH like that. So after reaching there, you need to remove this NH2 there, but it cannot live on its own because it is a poor leaving group. So we need to protonate it. Remember here, after getting the hydrogen, what we have is an acid. Yeah, an acid. So this is an acid. So here I'm going to use the lone pairs from the nitrogen there and bring the acid D. So here this is the acid D, like that. So here, okay, getting this hydrogen there. So when I get this hydrogen there, so this bond will break and all the electrons will go toward the oxygen. Okay, so here, what am I going to have? I'm going to have something like this. Okay, I'm going to have something like this. Okay, so something like that. So here, then here, we are going to have NH3 with a positive, because we have now it is attached to 4 bonds, so it is positive. It has become now a good leaving group. So what am I going to do? I'm going to expose one hydrogen there and get the one that has remained here, which is after getting this hydrogen there, we have remained with water. So that's water, the one that I'm going to bring here. This is water, and we'll come and get this hydrogen there. Then this bond will come and make a double bond there, making this ammonia to leave as a product or byproduct. But that is not our main product or major product. So we are just concentrating on our major product like this. So like this. So here we have N. So something like this. Okay, so here like that. So here there is a double bond which has formed like that. So this is how you come up with this. You can have also the byproduct. So here there is hydrogen, remember. We can have also the byproduct, like after making this one, you remain with the acid. When you started with acid, that was a catalyst. It's catalyzing the reaction. So a catalyst is a substance that speed up the reaction without itself being changed at the end of the reaction. So that is this. We have remained with an acid, the one that we've started with. After getting the hydrogen, we have an acid, plus this, which is an ammonia, which has left like that. That is a gas, ammonia, that has left here. Remember, when the ammonia left here, this one. So the main product that we have, the one that we wanted, is that one. That is Fischer synthesis of indole. There is tautomerism. There is this breaking of bonds, reacting like that. So yeah, that's that. That's how you come up with the Fischer synthesis of indole. So that is the reaction there. Thank you so much, guys, for watching this video. If it's your first time, please subscribe so that we may be working together. Dr. Brennery Wabonse.